Okay, welcome again. Now, Newton's method we discussed here. The method uses the same idea as the Newton's for the one variable. But don't forget, guys, in one variable case, we uses the iterational process for Newton-Raphson method by considering root finding. To find out a root, we have known that we have a function. Let me rewrite here. We have a function f of x will give you as a result 0. So the right side should be all the time 0. So by using the Newton's method, the Newton's method is used for finding the root, as you know, the right side should all the time be 0. For this reason, we will continue with system solution combining with root finding idea. Okay, now we have applied our Newton-Raphson method to the nonlinear systems. So for this reason, I'm defining here 2 by 2 system. Okay, so f1, xy, which are unknown variables, x1 and xy are unknown variables for us, whereas these are the equations. f1 and f2 are the equations. And our main purpose here, this is corresponding to, for instance, guys, xy, which is giving a matrix, will equal to B form. I cannot write down here xy just the linear form, so maybe you can say that xy, which is your nonlinear version, and there exists another vector which corresponding to the unknown vector like xy in transpose form. So to apply Newton-Raphson method, we have discussed here f1 minus b1 will give you 0, f2 minus b2 will be 0. Why we discussed it? As you know, we turn it into the root finding problem. This is so important. Otherwise, because we know that Newton's is used for root finding. Okay, this is the important thing, root finding case, because now we will continue with here defining here f of xy. Now guys, from now on we have defined just the notation, okay, just writing another notations to understand it. Do not confuse with these things, because now just doing a rearrangement by giving some definitions. Here f of xy will become as in that form. In the f of xy, I'm defining in matrix form, because now we are dealing with nonlinear systems. Okay, nonlinear systems. Okay, so here is our expression f1 minus b1, f2 minus b2, because root finding version is also valid to apply Newton-Raphson method. And I'm defining here big X. This big X defines me a vector like x and y respectively in transpose form. Now, as you know, the Newton's method says us in one variable. Let me write here, opening a box to you, and I wish to write here my Newton's method will give us in one variable is xn minus f divided by f prime. Now, using the same thing, we are using the same process, same scheme to apply the vectoral form, because my vector contains here two different components like x and y. Because of this, we are using the superscripts to denote the iteration process of the vectors form. This is iteration. Okay, so the problem occurs here. Big F1, this is a field, this is called a field. So now we ask ourselves, what about how can I find out the derivative of this field? Because guys, I have two variables, so the derivative means that I should take here with respect to which variable, with respect to x or with respect to y. So the problem will become here, how can we define f prime in terms of x and y? Now, for this reason, you have here another definition which is called Jacobian. The Jacobian of a matrix is corresponding to the derivative of f with respect to big X. This big X, please do not forget it. This big X is giving us, let me write here, this is actually in vector form x and y in transpose form. So for this reason you do not forget it for the Jacobian matrix. Okay, in the Jacobian matrix we have discussed here our Jacobian matrix will come from del over let me do for it, sorry, for it, wait a minute. Okay, we have known that the Jacobian says us here, Jacobian says us, first of all, first component of f, and with respect to x1, so x1 here is denoted by x now according to our expression, and then first component of field with respect to x2. In some books, these are also the corner points, I mean the second one, the first row second column or second column first row are sometimes are written differently, but does not matter. Okay, we will continue here this definition. So it is again a problem for us and for you, I know. So let's see on the application in our problem. As you know, in previous our field, so we have seen that we have discussed our field. This is called big F1, whereas it is the second one is called big F2. Okay, so because of the component-wise version of my field. So we will continue with f of 1, big F1 corresponding to small f1 minus b1, small f1 minus b1. And here taken with respect to derivative with respect to y with respect to x case. So totally guys, Newton's method for the system becomes, as you can see here, your expression. From now on, instead of Jacobian guys, is corresponding to, actually maybe we can, roughly speaking, if we are speaking roughly, this is corresponding to f prime big X. Okay? So let's see an example to understand it better. It is more helpful for you, I think. For this reason, let's see how we deal with the solution. Okay, example, use Newton's method with x0 as 0 to compute x1. Do not confuse with the superscripts. The superscript 0 means that initial guess, this is initial guess. Okay. And x1 will be the first iteration. So we have discussed here how we find out here, applying how we deal with the application of the Newton method. First of all, I want to emphasize that this x0 guys is written as 0. This means that because you have x1 and x2, two components which are unknown, x1 and x2, we don't know the expression. Let me erase it. So x1 and x2 are unknown for you. It means that big x0 is actually guys 0, 0. So they are corresponding to x1 0th iteration, x2 0th iteration. Okay, you should know it. So let's see how do we solve these problems. Okay, sorry for, yeah, maybe we can continue with it. Okay, again we clarify here all these things. F1 will be specified, F2 will be specified. Do not forget, this is the important thing again for us. I'm writing here, the right side is already 0. Okay, we accept it is already 0. What about here big F? Now the creation of big F corresponding to respectively writing here f of 1 and f of 2 into the matrix formalization. So f of 1 will be here, f of 2 will be substituted in the second component. And we also have discussed here x vector, which is our solution vector and which has two components like x1 and x2. And x0, it is looking like a power, but it is not a power. It is in numerical methods, it is written like the iterational process for us. So we know that it is already given to us like the 0 vector whose components 0 and 0 for corresponding to the 0th iteration of x1, 0th iteration of x2. Now we have applied here our Newton's method, which is given as in that form: xk plus 1 minus xk minus Jacobian inverse f at xk point and then f of xk. Now, to obtain here the Jacobian inverse, first of all, of course, we should define here Jacobian itself. The Jacobian value here, look at here, I'm just applying the formalization of the Jacobian. We have known that here our expression will turn to the derivative of f1 with respect to x1 first of all. Now it defines us here 8x1 minus 20. Do not forget, this is your f1. It is f1, this is f2. So taken here the derivative of f1 with respect to x2, it means that 1 over 2 x2. What about f2? The second row will be filled in the matrix formalization to obtain the Jacobian matrix. F of 2 with respect to x1. Now I'm dealing with the second row of the field. The second row of the field says you f of f2 with respect to take the derivative that derive the function f2 with respect to x1 is corresponding to 1 over 2 x squared and plus 2 should be, and then the derivative of f2 with respect to x2 will be x1 and x2, x1 times x2 minus 5. Okay, by putting here, you will substitute from now on the 0th point. The 0th point is what? It is actually 0 and 0. So you have taken here your x1 is 0 and x2 is 0 respectively. By taking them, I'm getting here my expression Jacobian matrix will come from here at that point. It gives me minus 20, 0 and 2 minus 5. So you have known that we should obtain here because of the derivative, because of the inverse formalization. So we have obtained here the inverse of this expression is coming from, guys, we just write here I have just defined to you who didn't see linear algebra up to now. So I'm giving here the definition for 2 by 2 matrix inverse formalization. So you can also use your calculators to calculate here the inverse of a matrix. So the inverse of this matrix will giving us here the inverse is coming from that one. So let me rewrite here this expression is the Jacobian inverse f, okay, at the point x0. Then the 8 will give you your field at point x0, and this is your initial guess, which gives you x0. Totally, we have obtained here, guys, the point initial guess, one step solution we are discussing, initial guess minus the function, roughly speaking, function derivative, 1 over function derivative, and times f at that value. So the answer giving us here 0.56 and 1.6. I wish to give here and homework for you. Apply one more time Newton-Raphson method to obtain x2. This should be better. The parentheses usage on the superscript is better, I think. So you can use the parentheses to show here iterational process. Okay, here is the iterational process. So I wish to give here all the code, all these things, okay? So let's start to MATLAB coding if it is possible. We will try, we will see. See you in the next course.